So this video that I am doing is about integration by parts. So to begin, integration by parts has a specific formula, as you can see on the very top here. And this integration by parts formula is derived from the product rule. So the product rule states that the derivative of u of x times v of x equals to u of x times the derivative of v of x plus derivative u of x times v of x. Now, from this formula, we can see that u of x, v of x is the antiderivative of the right-hand side. So we can get our second line, where u of x, derivative v of x, equals the integral of u of x, derivative v of x dx, plus the integral of derivative u of x, v of x dx. So now, from that formula, if we move the second integral on the right-hand side to the left-hand side, then we obtain the formula integral u of x, derivative v of x, dx equals u of x times v of x minus the integral of derivative u of x times v of x dx, which, as stated prior, is our integration by parts formula. So now, if we examine this formula for integration by parts, as listed above, we can use this example set forth before us now to display integration by parts at work. Now, before I explain the example, a quick thing that must be understood is that integration by parts is strictly used when you are looking for the integral of two products, and these two products are in no manner related. So that is to say, in this case, if we look at our example, integral x squared times sine x, the product x squared has no relation to sine x. That is to say, in no manner can we use u substitution, du, or any other property that we would have thought of, because one of the products is not the derivative of the other product, or vice versa, one product is not the integral of the other product. As such, we take our two values and we must plug them into our equation. So in this case, we have the integral of x squared times sine x. So what I chose to do in this situation was I chose to set my u of x as x squared, as I feel it would be easier to take the derivative of that, and in that case, it'll be 2x. And I set my v prime of x as sine x, as I thought that would be the function that would be easier to take the integral of, which would be, in this case, my v of x would be negative cos x. Additionally, the manner in which you know which one to set as your u or which one to set as your v prime is eventually you want to have one of your products be able to be settled down to a pure number like 2 or like 1. So as we can see here, having taken the derivative of u of x and gone into 2x, when I have to further again do integration by parts later, I'll get it down to 2, so then it'll be easier to work with. But as I stated, I made my u of x, x squared, so therefore my u prime of x was 2x. My v prime of x was sine x, and therefore my v of x was negative cos x. So as you can see here, I plugged this into the equation. So I got the integral of x squared sine x equals negative x squared times cos x. So that's my u of x times my v of x, minus the integral of 2x times negative cos x. So as you can see from the equation, in this case, that's the integral of my u prime of x times my v of x. So now once I'm at this point, I need to find the integral for the chunk that is the integral of 2x minus negative cos x, which means I need to do another integration by parts within this formula. So now I had to set a new u of x and a new v prime of x with my values of with my products of 2x and negative cos x. So as stated earlier, my goal was to get it down to a whole number such as 2 or such as 1. So I set 2x as my value for u of x, which means my u prime of x was equal to 2. I set my v prime of x as negative cosine x, and then my v of x was negative sine x. So now I had it, with my next line, I had it equaling negative x squared cos x minus, now to find the integral of that portion above, 2x minus cos x, I had to do integration by parts for that formula. So you have negative x squared cos x minus negative 2x sine x minus the integral of negative 2x sine x. And once I took the integral of that formula through my integration by parts, I got negative x squared cos x plus 2x sine x plus 2 cos x plus c. And so that is my integral for the entire thing, where I had to use integration by parts twice. Thank you very much.